In the next slides, we see. Hello. Okay. In next slide, we will see the QR code coils which are labeling for the identification of each coil. As you can see from this picture, we are mentioning the grade of the coil as well as the coil number, the diameter, the heat number, as well as the date of the production and the shift of the production. This is the QR code which we are labeling in the each of the QR code, our coil. The plain rods coils, as sir explained, that we are producing two kind of grades. That is IS 7887. In that we are producing a different kind of grades. That is grade 1 CAQ. CAQ is for cable armor quality. Then grade 2, grade 3, grade 4, and grade 7M. Uh, as well as that, we are also producing a IS 2879 EWNR, which is a electrode wire non-rimmed one. This is as per we are producing IS 7887 grade 1 CAQ, and in a grade 1 CAQ we are producing a 5.56 mm, which are further drawings to make a wires for cable armoring. For chemical composition which we are using, for that our carbon is we are using a 0.06 max, magnesium 0.35 max, and in a CAQ especially we are measuring the resistivity, which is the maximum limit is 13.5 into 10 to the power minus 6 ohm centimeter, and tensile strength which we are using for CAQ as max limit is 400 megapascal, and then the reduction area is 70% minimum, and nitrogen also we are measuring for it, and we are reporting like the maximum limit is 19 ppm max. Why resistivity plays a so important role in cable armor quality? As I said in the previous slide, this cable armor quality wire rods are further drawn into a for the cable armor one. So basically, copper and aluminum wires are used for they are known as a good conductors, but they are soft to provide the support to dam as well as to provide the we are using a cable armor quality as in steel wires, so that it will act as also support to them because they are very much soft. Also they will if any shocks is there, so it will act as a earthing purpose also. So because of that, resistivity plays a major important role, so it should be a good conductor, so resistivity should be low as minimum. As you can see from the picture, this is copper and aluminum wires, and based on that steel wire sheath is installed. And in our wire rod mill, we are measuring the resistivity. This why we are using a resistivity measurement instrument, where two probes are, as you can see from the picture. Video is also there if you want to see. Okay, so this is wire rod mill's resistivity measurement machine. Here, as you can see, this is a four probe machine. Here, the two wires are basically used to provide the current to the. This is wire rod mill samples. Almost 1 meter samples we used, and after that, this two probes are used to provide the current to the probe. Sorry, wire. And after that, the whatever the voltage changes, this can be measured by these two wires, and the voltage based on that resistance it can give. And by using a formula, that is resistance equals to resistivity by rho L by A, length upon area. Based on that, we measure the resistivity of material. Another grade which are producing in a plain wire rod, that is EWNR, electrode wire non-rimmed, where we are producing the wire rods of sizes 5.5 and 6 mm. And the chemical composition is 0.10 max for carbon, and the manganese is between 0.38 to 0.62. Silicon is 0.03 max. Sulfur and phosphorus, which are using, are 0.025 max, and aluminum is 0.012 max. In this slide, we will, this is like a combined version of whatever the chemistry and the sections which were rolling in the wire rod mill for the plain one. So this is as per IS 7887, grade 1 CAQ, and the grade 2, grade 3, grade 4, grade 7M. And the IS 2879 is for EWNR, and 7904, this is for high carbon one. HC38B, we have also rolled in that one. This is the chemistry where almost for grade 1 carbon, which are using a 0.06, grade 2, 0.08, 0.10, and the grade 4, 0.08 to 0.13. For grade 7M, 0.15 to 0.20, and the for 2879, 0.10 max. And for 7904, for HC 38 bit, 0.35 to 0.40. And this is another type of, this is the tolerances which we are using for the plain wire rods. As you can see from the picture, the rods which are producing mostly 5.5 to 6 mm which are producing, and these are the this is as per the standards. These are the sectional 186 and for the 6 mm 0.222. And the tolerances which we're getting, this is as per this, so plus minus 7% in a sectional weight. And the tolerance, the wire rod should be tolerance on the side is 0.5 plus minus, and the ovality should be 0.65 max. We try to get the wire rod's coil should be follow this tolerance level, and it should not cross this tolerance level. As everybody knows the TMT, but still I will talking about the TMT. So who will not know that TMT is thermomechanical treated brass. As per the name suggested, there are two kind of terms, that is thermal and mechanical. The mechanical means rolling size reduction, but the thermal, it has a two kind of additional process, that is quenching and the tempering, which provides the TMT such a kind of a structure that its outer core will be the tougher, it will be have a higher strength, and the inner core will be the more softer. So it will give the perfect combination of the strength as well as the ductility. So as you can see from the process, after coming from the stand, this will be in a hot state. So it will be the structure of the bar will be in austenite converter. After it goes to the cooling quenching box, it will from the water boxes, it will get quenched. Outer surface will get quenched, and it will provide a martensite structure in the outer layer. As soon as it will go to the cooling bed, the inner structure which have still in a hot region, it will pass its heat to the outer region, and it will get tempered. So such a way that as you can see from this picture, then this is the microstructure of one of the TMT. Outer rim, as you can see, this is black. This is a tempered martensite structure. Inner rim is benite, and this is a ferrite and pearlite. So this gives our perfect toughness or elongation, and this gives our perfect strength to the TMT. In wire rod mill, we are also producing the TMT. Hello.
Lilia, continue होगा मेरा.
In wire rod mill, we are producing the TMT of a different profiles. That is the sizes which are producing 8, 10, and 12 mm. And the grades which are producing, that is EQR FE 500D, EQR 550D, Cell Secure 550D, or HCR 500D. This kind of grades which are producing in a wire rod mill and TMT. We are, as being a RCL, we are also monitoring the process in the wire rod mill based on the we are monitoring the levels of equalization temperature, that is the laying head temperature, and the quenching water pressure. In water quenching process, how much water pressure we are applying for the quenching, and how much water volume we are applying, that we monitor for the TMT. And the process parameters like a mill speed and furnace temperature, this also we monitor. This is one of the example. As you can see, this is the 101 nm³ per hour. This is the water volume, 17.57. This is the water pressure, and this is the intermediate layer, intermediate temperature 981, and 545 is the laying head. That is basically equalization temperature, which we measure. And the buckets which are we are producing a very much grades in a TMT. So this sale TMT EQR mostly used in a various kind of applications, like concrete construction. This sale TMT EQR is used for the earthquake resistance, and because of its excellent bendability as well as the weldability and high fatigue resistance on a dynamic loading. Sale TMT HCR, as know from this chemistry, it is based on the high corrosion resistance. So mostly it can be used in a coastal or marine or underground environment portion. It not only has a like EQR kind of properties, but also high corrosion resistance properties. And as a 2879 EWNR, this is arc welding electrode, which we mostly use for the welding purposes because of its very low carbon, manganese, and silicon. And then grade 1 CAQ, as we explained in the previous slides, it's used for the cable armor qualities purposes. Now we will compare the mostly grades about the properties about the FE 500D and 550D. So in a EQR TMT, as I said, we are producing 8 to 10 mm for 8 to 10 mm TMT, where carbon for 500D and 550D are almost similar, 0.25% max. Sulfur and phosphorus also is same, 0.040 max. But YS ratio is 500D for 500 megapascal minimum. For 550 is 550 minimum. But TS by YS ratio for 500D is 1.10, but 550D 1.08. And elongation is 16% minimum for 500D and 14.5% for the 550D. And the bend test also, will be mostly. Okay. For bend test also, the 500D, the required dimension is 3 into diameter of the rod. And it is in case of a 550D, it is a 5D. And for bend test, it is in case of 500D, 4D, and the 550D, 6D. Now we will mostly see the another grade which we produced recently in a last this month only on 3rd May, that is Cell Secure 550D. Now we'll compare with a normal our EQR 550D. As you can see from it, the carbon is almost similar in the case of a Cell Secure as well as in Fe 500D. But in a case of a sulfur, but in a case of a sulfur, our sulfur is minimum. We are keeping the sulfur in minimum cell secure, that is 0.035 max. Phosphorus is also a limit which we are reducing compared to the EQR 550D, that is 0.035. Sulfur and phosphorus addition, which we are keeping in a 0.075 in case of 550D, but in a cell secure, we are maintaining a 0.070. Not only chemical properties, we are also changing the mechanical properties in case of a cell secure. As you can see, not YS like 550 are almost similar, but tensile strength, that is TS, which we are keeping is 600 in a 550D, 15% higher than YS in a case of a cell secure, that is almost 630 to 632. And then UTS by YS ratio, which plays a very important role in a like application of TMTs. So in a case of a cell secure, we are keeping that ratio, that is 1.15, but in a case of a 550D, that is 1.08. Total elongation also in 550D, we are keeping a 14.5, but cell secure 16. And the bend for the bend test, the nominal diameter is for up to a 20 mm dia, that is 4D, and for about 20 mm 5D in case of a 550D. But in a case of a cell secure, it is we are reducing it to 3 to 4D. Again, for the rebend test, again it's same, up to 10 mm it is 6D, about 10 mm that is 7D. But in cell secure case, we are again reducing to 5D to 6D. This is a picture of
Excuse me, Bharti. You told
yeah,
that you have produced Secure recently. That means
yeah.
this is the first time that it was done.
Ma'am, you are not audible actually. Can you speak louder?
You said that you have recently produced Secure.
Yeah, ma'am.
So
In
was it
wire
done
rod
for the
mill,
first
actually, we
time?
produced the first time, ma'am.
Okay, carry on.
So as you can see from this picture, from here the sealing and the strapping is done for the wire rod mill sections. After this is after reforming tub, the coil falls down on the pallet, and here the strapping is done. After that this coils get collected in the coil collector, and further it will go to the yard. We will in the next slide we will see the how we are doing the inspection. So basically, this is a coil collector. Reforming tub, after that the coils will fall down on the any kind of no lug is there, or any kind of a quality checking purpose, we'll do that here. Hmm. Even as we can see in the as I explained the tolerances which we are checking, we will do it here only. That ovality is there, or any like sites or any out of tolerance are there, which will inspect here only.
Here I would also like to tell another thing, that this is generally a very broad and general kind of inspection, and for a specific inspection, 3 times in a shift we are collecting a sample from conveyor, and this small sample is measured for ovality, for tolerances, for in case of TMT for weight per meter and the projected area, then DTR, transverse rave, longitudinal raves, fin to fin, and weight per meter. So this is a specific inspection which we are doing after collecting small sample from the conveyor, and the video which was shown just now is a broad or generalized kind of inspection to find out any multi-end, any bad shape kind of thing.
Now we will move on to the testing facilities, like where we are testing this wire rods and coils, and as well as the TMT coils. So we have a rolling mill lab where we are testing this. So testing facility which we have in RML, that is a first of all we will talk about the tensile test. So we have a different kind of a UTM machines. So in RML, so basically we have 60 ton and 100 ton to 200 ton machines, where 200 tons we have two machines, and for 100 ton we have three machines, and 60 tons we have two machines. This is a UTM machine. In next slide we will see the how we are measuring the how we are doing the tensile test. Okay, so first of all we are doing the punching to we are punching for the gauge length measurement. After that After that, we are measuring the inner, first of all, we are measuring the diameter of it, of a sample. Then we will put this sample into a machine. And then after that, we will start the analysis. And here, from after starting the analysis, we will get the curve, which we all known as a stress strain curve. As you can see, the curve has been started. As you can see, it after from here, this is YS. Okay, we will see the next slide. Okay, this is another video which is will clearly show the how stress strain curve formed. After here, the plastic deformation will get permanently get deformed. From here, this will show the YS, and after that, we will get the uniform elongation. As you know, as you hear the sound where the sample got fractured, that will be the limit of a fracture. So uh, as you see in the video, we have taken one sample. After breaking down, it will look like this. This is wire rod mill samples, and after that, we will measure the diameter of it. Initially, also we have measured the diameter of a sample, and based on that, we will calculate the RA reduction area, which have a formula like A0 minus like initial area, initial cross section area minus final cross section area upon initial cross section area into 100, which we talked about mostly in a CAQ grade, which we are giving the reduction area 70% minimum. For that, we are calculating this. And again, this slide will give a more clarification. As soon as the testing is started, from here until here, the material is just elastically deformed, and after that, it will get permanently deformed. Again, the stress will get increases until this. Here, this will the maximum load. This will give the UTS, and after that, fracture will be there.
Yeah, here I would like to interrupt a bit. As we have recently developed cell secure grade. Recently, we have developed the cell secure grade, and the unique feature of this cell secure is the ratio. I would like to talk a little bit about this ratio, why this ratio is important. As you see, it is a typical stress strain curve where till this point, where it is yield stress, the steel deforms elastically. That means, suppose we give load till this point and we withdraw the load, the entire deformation which has been subjected to the steel sample or steel product will be withdrawn. It will revert back to its original shape. So till this point, this is the yield strength. This elasticity continues. That is why it is, and for my metallurgist friends, they must be knowing that this is Hooke's law is followed from this to this, and this after this plastic deformation starts. Plastic deformation starts. That means suppose we give load till this point, and then we withdraw the load. Then what will happen? Till this point, the deformation is this much. So what will happen? The elastic component, that is this much component, will be withdrawn, and the remaining will be remain permanent. That is the plastic deformation. So here comes the importance of the ratio, that is UTS by YS, which is 1.15 minimum in case of cell secure grade. Whereas for the same 550D without cell secure, that is a normal IS 1786, it is only 1.08. So why from 1.08 we are giving 1.15 minimum? See, the more this area will be from this YS to UTS, more ductile or more prone to this earthquake resistance is there, because from after this is the area of plastic deformation. The more this area is, the more desirable it is. So all designers will like to have this gap is as wide as possible. So in wire rod mill, we have recently on 3rd May, as Madam told, we have developed this grade. Around 500 tons of coils have been produced for the first time in Bhilai Steel Plant in surgical grade. These have been dispatched to Bhilai stockyard, and they are in the process of decoiling and further straightening. Then this is supplied to different customers, and after getting the feedback from the customers, we are planning for further production of this grade.
For chemical analysis, we are using a OES machine. So in our RML lab, we have two OES machines. That OES means optical emission spectrometer, which is used for the chemical analysis. And the making of this OES techniques are both thermoscientific one. There is another video of how chemical analysis being done in OES. So as you can see, this is another TMT samples which getting placed on the electrode. After that, electrode is placed on that TMT, and it is actually optical emission spectrometer is totally based on the spark spectrometer. As you can see. So basically, the optical emission spectrometer works on the principle that's spark generation method, that is energy getting provided. So because of that, the items electrons get excited to higher orbit, and as soon as you are removing the energy, it will go to the lower state. So that because of that, it will release a particular wavelength or photons. These photons have a unique wavelength, and wavelength is a unique characteristics of a unique characteristic for each elements. So there, actually, we are also using a certified reference materials, that is CRM samples. So to draw the calibration curve, by recalculating it, it gives the concentration. That is the main principle of a optical emission spectrometer. And almost one spark test we give in like 40 seconds, but we do the multiple sparks, so we provide the average value. So for nitrogen, as I told in a CAQ, we are measuring the nitrogen, which we are reporting almost 90 ppm max. So for nitrogen analysis, we are using a nitrogen analyzer. We have two nitrogen analyzer, that is they have different making. That is one is ultra analyzer and one is Horiba analyzer. The process is basically I will just say the principle of nitrogen analyzer. Actually, in the nitrogen analyzer, first of all, two kinds of samples which can be measured. One is a pin sample, another is a chip sample. But chip sample are getting oxidized easily, so it will be better to use the pin samples. These pin samples are first of all, their weight can be taken. And they first of all, and then log into the sample into the element software. After that, put that pin sample into this sample porter, as you can see from this picture. Sample porter, it is put in, and helium gas is used as a carrier gas, which will flush this sample. So any outside gases are there, they will be removed out. After that, graphite crucible is placed on this electrode, and after that, again helium, by using helium, we will flush it, so that the whatever will be the outside moisture is there, that will be removed. After that, based on the inert fusion method, that is the by using, this is like a furnace only. So this pin sample will get deported into the crucible, and it will get melted almost around 2000 to 3000 degrees Celsius. And based on that, oxygen, whatever in the pin oxygen is there, that will get reacted with the graphite crucible's carbon, and it will produce a CO. And it will and also hydrogen and nitrogen also get transferred into in an elemental form. They will go into the filter, and after the filter, the CO will go to the carbon oxide catalyst, that will get converted into a CO2. And by using infrared cells, we'll get the how much oxygen amount is there. For the nitrogen case, by using a thermal conductivity detectors, we can measure the nitrogen content, because we will already have some CRM samples of a nitrogen. Like, we will know how much thermal conductivity is there based on this nitrogen concentration, how much thermal conductivity is changing. Based on that, by recalculating it, we will get the nitrogen percentage. And finally, after the analysis, we will get the data, and we will export it into a LIMS. We have also the We have also the approvals. We have enable approvals. In 2023 to 24, we got the enable approval for our product testing in RML lab. We have also BIS, actually BIS license also. So as I said until now that we in Varod mill we are producing a different kinds of grades, like as for 7904 for high carbon one, we have a license of that. 2879 for EWNR, 7887 78 for grade 1, grade 2 and the CAQ. So for that we have this kind of a BIS license, and for TMT we have 17861, and these licenses are all operating. Now further we will discuss about the test certificate. These are our test certificates for CAQ cases as discussed for the whole time. We are providing the chemical analysis as well as the mechanical YS TS at their elongation and the TS by YS ratio, as well as we are also providing the reduction area. We are also reporting the reduction area, and as well as the resistivity also, and nitrogen ppm in case of a CAQ. In case of a grade 2, we are just providing the chemical analysis, chemical concentrations. And in a case of a EWNR also, we are giving the chemicals, that is carbon, sulfur, phosphorus, manganese, and aluminum.
Here I would like to interrupt a bit because I have seen Ayushi madam is also here. She actually visited recently Bhilai and she asked for some certain changes in the CWR TCs based on her feedback and based on the requirement of a customer. We have very recently modified this TC, and all the elements which are basically trace elements, and are not intentionally added. We have introduced these elements also in the TC, which were not there earlier. So, Ayushi madam, your job is done.
Yes, sir. Thank you. Thank you so much, sir.
Okay, madam.
Thanks a lot.
And this is our TMT TC. Here also we are providing the chemical as well as the mechanical one. And after that, just I said, in the 3rd May, we have produced the cell secure successfully in our Varod mill 500 ton. So this is the TC where we are providing chemical as well as the mechanical properties. Recently, we have done some improvements in our Varod mill in our process also. So based on that, so actually test certificates, initially we used to go, we now just recently started the digital signature in that. And based on the CMO's feedback that customer should know that the wire rod coils, what is the front end and the back end. So a few months back, we have started to put the paint marks in the front end for the better identification. So we have started that process, and also in 2023 and 24 we have taken enable accreditation. As you can see from the picture, that's not very clear, but still here we are actually putting the in a front end we are putting the aluminum paint, so that for a better identification that this is a front end and this is a back end of the coil. And in EWNR case also, we have started to reduce down by using a desulfurization unit. We have maintained that the sulfur should be in the lower level. That is our norm for EWNR. That is sulfur is 0.020 max. So as you can see from the table for the last few months back.
Here I would like to say that
हेलो
these
तो ये नागपुर से कन्वर्जन का मेटेरियल लेते हो तो उसमें प्लांट में क्या डालते हो और स्टोरेज
Bhavna
लोकेशन में क्या डालोगे
Sharma,
Madam Bhavna, can you please mute
Bhavna
the
Sharma,
mic?
ma'am, please mute yourself.
नहीं वहां का वेयर हाउस आएगा या क्या आएगा जैसे नागपुर है नागपुर का क्या कोड है हाँ
Oh, ma'am, can you
हाँ
mute her?
ये दुर्गापुर का है दुर्गापुर का
Bhavna Sharma,
I'm telling her.
okay, please carry on.
In case of EWNR, from the point of view of chemistry, recently we have done certain improvements. Our sulfur, as per the specification requirement, is 0.025 max. Generally, our sulfur used to hover around 0.015 earlier. Now, seeing the TCs of other customer or further manufacturers, and based on the feedback from the customer, we have reduced sulfur to the level of even 0.005, and the average sulfur of our recent 2 or 3 campaigns is 010. Here I can commit that if there is a positive feedback on this improvement, we can further reduce it. In fact, our top management is telling us to further reduce it if there is additional premium. CMO can give some feedback that yes, we can fetch certain additional premium. Then we have desulfurization facility in SMS3, and we can further reduce it to 0.004, 005 level. So that is the kind of improvement we have done. Also, carbon, which was earlier 0.09, 0.10, based on the feedback of the customer, we have reduced this to 0.06, 0.07. And silicon, of course, is 0.3 max, and aluminum is 0.12 max. And yes.
Not only we have done some improvements, but our wire rod mill is an older mill, so we have a bit of constraints and challenges also. So as I said, our mill is very much older. So because as we seen in the layout of the wire rod mill, that C and D stand have a Stellmore conveyor. So because of that, the wire rod gets stuck in that, and we have to cut it. So because of that, our coils get multi-ends problem, and it suffers from the bad shapes also. That is another technical constraint. Another technical constraint is that almost front to almost 3 to 4 rounds in the front and both in the back end, we get the fins. And these are our customers. And almost.
Yeah, one more constraints which I would like to tell in case of TMT is that our front and back end, certain rounds are not having the requisite properties. So invariably these coils we cannot sell directly to the customer. These coils are sent to only designated stockyards where decoiling facilities is there. I think there are only 7 stockyards are there, which are where our wire rods are, where TMT coils are supplied. There around 20 rounds of each in front and back end are cut, and they are basically diverted to scrap. And this is around 60 meter, around 8%. It comes around 8% of the entire coil weight. That is the biggest constant. And not only wastage, but one additional step is required in stockyards. So, and we cannot directly sell it to customer. It is because it is old mill. We don't have any logistics to cut these front and back ends at our mill itself. So we have to live with this reality. And another constant is that since our mill is old, our billet weight is only 1 ton. So we cannot produce more than 1 ton coil. Whereas most of the big manufacturers like Tata, Jindal and all, even ISP, Vanpur, they are producing 2 ton coil. So customers are telling multiple times that coil weight should be minimum 2 ton, or even 2.5 ton coils have come into market. So here we are helpless. We cannot do anything till if a modern new mill comes, which some discussions are going on, and hopefully it will come in near future in Bhilai. Then definitely will produce not only higher weight coil, but also certain new grades, which at present we are not able to make. There are very high-end grades also of wire rods, which ISP is making and which we are not able to produce, like MIG, like PC115, LRCPA, and other certain special quality wire rods. So hopefully our new wire rod will be approved at a higher level, and we will be able to produce these grades also. So here I would like to end our presentations, and we would like to have certain questions or queries or doubts by our CMO friends. We'd like to take those questions.
Sir, I would like to thank you for a very good presentation, sir, and explaining. I just wanted to know the detail of that 3 strands and how they operate. Can I get to that slide, please?
Can you repeat?
Can you please introduce yourself also? Whoever is asking the question, please. एक तो आप आपका कैमरा ऑन कर लीजिए और अगर इंट्रोड्यूस करके कोई सवाल पूछिएगा तो ज्यादा अच्छा रहेगा.
Yeah. Well, sir, thank you so much for a fantastic presentation. I just wanted to know some details about that 3 strands of rolling and the sizes being rolled. Why it is 2 different sizes being rolled, sir? I am J.N. Kar from Headquarter Marketing.
Basically, we have 3 strands in B, C, and D, and
गोयल सर आप थोड़ा सा तेज बोलिएगा, आवाज नहीं आ रही है.
As already told, in B strand is a recent modernization has been done, and C and D are a bit older in terms of modernization. So each strand has certain limitation, and that is why we cannot produce all the thickness in all the strands. It is applicable for wire rods as well as for TMT coils. For example, in B strand, we generally do not produce 8 mm. In TMT, we produce only 10. So likewise, there are certain technological constraints which prohibit us for this universalization, that we cannot produce all thicknesses in all the strands. So that is a limitation. I think Anupama madam is also here. She can throw more light. She's on this. Madam, Anupama madam, are you there, na?
Actually, we are trying to take a trial order for EM12K, the sub-arc electrode for EA.
Yes.
So there the requirement is the requirement of the customers are mostly in 5.5. But as we have discussed with the plant that some amount of 6 will also be required for that. So my question is related to that. It is a
Yes,
product
yes,
development exercise.
I appreciate your concern. 6 is the must for enhancing for keeping the productivity of wire rod mill. We can produce only 5.5 also, but that will require only 1 or 2 strands to be in functioning, and 1 or 2 strands has to be kept on hold. So that will
No, why that on hold? Just I wanted to know that why it is on hold. That
because
is
the technology of these stands are different. As we already
okay.
told, in stand B, it's the most modern stand. Even that is the last modernization was done in 2005, and C and D are further older. Their last modernization was carried out only in 1995. So because of this old technology and technology constants, we cannot produce all the thickness and all the stands. That's the
No,
reason.
when you operate all three stands, or it is
Yes,
on
yes, yes,
stand one?
yes, yes, yes. It is basically, you can say, it is 3 mills. It is in practically we can say we are running 3 mills in wire rod mill. All 3 stands are basically three different mills. Only common thing is furnace. And after that, each billet is rolled separately. Till stand 15, as you can see the layout, uh, till stand 15, rolls are same common. But after that, even rolling is done in different stands. So each stand, this is B stand, this is C stand, this is D stand. Technology is different. This is the block technology is different. It is not possible to roll all the thicknesses in this.
So at one point of time, you are rolling two sizes, minimum two sizes is being rolled,
Yes,
whether it
yes.
is a wire rod coil or a TMT coil. What the statement is correct?
Yes, yes. We are at simultaneously we are producing two thicknesses. Let us say it is suppose TMT we are rolling. So it is here we are producing 10 millimeter. Here we are producing 10 millimeter. Here we are producing 8 millimeter. In case of
Okay.
wire rods, we are producing
Got
6
it.
millimeter here 6 millimeter. Here in D stand 5.5.
Okay, got it.
Any more questions, please, before we break for
Good afternoon, sir. I am Devashish. I am from Bombay branch. Sir, I have a question that in case of wire rods, many consumers ask that how much drawability our wire rods have. Like if they can drop to 1.2, 1.5 or less than that. Generally, we say that from our 5.5 or 6 the customer can drop to 2 So can we say something about these two customers?
As far as the drawability is concerned, the thumb rule is the leaner the chemistry, the drawability is more as far as the chemistry is concerned.
Okay.
So if customer is facing certain problem in drawing through lower diameters, we can suggest two things. Number one, if he is taking 6 millimeter, we can ask him to take 5.5. Number two, we can ask him to, suppose he is taking grade 3, we can suggest him to take grade 2 or even grade 1 also. Because as we go lower in this categorization of grades from grade 3 to grade 1 to grade 1, this chemistry is leaner and drawability is more. So that is the thing. But our wire rods, Bhilai rods I know are being drawn up to at least 0.8. I know.
And sir, one more question regarding TMT coils. As we all know, there is a problem of cutting end portions. There's no alternative method other than that disposable action for cutting.
Actually, yes, it's very good question, very pertinent challenge for sale for Bhilai wire TMT coils. We have a BRM also, bar and rod mill, where there is a facility to produce this TMT coils also. This is the most modern mill set up in around 2018. Here we produce certain TMT coils also around in 2019, 2020, even till 21. There we were cutting these front end and back end rounds which were not having the requisite properties. There is a dedicated platform for that where these coils are taking in a conveyor, and these front ends and back ends are cut in the mill itself. But unfortunately, this wire rod mill is very old mill, and this kind of when it was set up, this kind of thing was not envisaged. In fact, in 1960s, there was no concept of TMT itself. So definitely, this kind of things were not envisaged. And now there is no logistics to introduce this kind of thing.
So one thing I wanted to ask, there's a provision in BRM. It means the issue is of SMS, not of the mills. Because if the same
You
issue is
must
in
be knowing that
BRM,
BRM is fully booked for TMT.
but the same
So
issue comes in BRM material also, and the same issue comes in WRM material also. So the issue is not related to mills; it is related to SMS.
yes, it is a technology itself, TMT technology in of TMT coil, that
Okay.
the initial few rounds and back few rounds will not have the properties. It has to be removed from the coil
And
before
all
dispatching to
other
customer.
producers would be facing same problem. Like us.
All producers do this thing. Only
Okay.
difference is that modern mills have this facility to
But-
remove these ends which are not having properties.
Hmm.
Unfortunately, this our wire rod mill is very old, and this doesn't have the logistics required to remove these rounds.
Okay, sir. Okay. Thank you. Thank you, sir.
Okay, thank you.
Any more questions, please?
Sir, namaste, madam. Sir, Rohit Huda this side, sir, from Bangalore branch, sir. I have
Huda
two,
ji,
three
please.
questions, sir. First, sir, this one slide where you have shown that you have supplied secure, sir. So what was the TS by YS ratio maintained, sir, in that?
Sales Secure, actually, earlier Sales Secure was around 3 years back, 500D also was there. But from last 3 years, Sales Secure is produced only in 550 grade in entire sale. And the required ratio of UTS by YA is 1.15 minimum. And if you
Yes.
compare it with the normal grade, we also produce EQR 550D, which is
1.06, I think.
1.08. It is 1.08.
Okay, sir.
So there is a drastic radical improvement in terms of ratio from 1.08 to 1.15. That is a unique property of Sales Secure.
Okay. And the second question, sir, this in one slide you have mentioned, sir, you have added the grinding and all those also like some changes you have incorporated. Sir, what will be the benefit of all those grinding and all one slide where it was mentioned, sir?
Grinding, that grinding machine, oh, that is ring grinding machine. Oh, that ring grinding machine we have recently introduced. This is basically, it will improve the surface finish of the wire rods because it will have modern, the final rolling of wire rods
Yes.
and TMT coils is done in rings, through not through rolls, but through rings. So
Yes,
we
sir.
have procured one machine which will be grinding this rolls through CNC technology. So it will help us to produce wire rods and TMT coils which have better finishing, surface finish, and better tolerance also.
Okay, sir. Sir, third question, sir. Actually, when I am going to like my customers, sir, mostly they have the, 2-3 common feedback, sir. One is fins ka jo issue hai, sir, which comes in direct dispatch also. The multiple cuts wala jo issue hai, sir. Scale loss and our material is hard in malab, not consistent basis. 1 month it is very good, and say next month there is an issue of hard material, due to which and that flat material, the photo that I shared, sir, ekdam matlab flat material, sir, as if someone has made that flat intentionally. So
Yes.
how to reduce all these things, sir? Because problem, sir, because we don't have any, I don't think chemical there is an issue, sir. This physical part actually which is having issue, sir.
Huda ji, isme we like to tell that as we have already told, because of technology constants, our front and back ends have the fins, and these we cannot get rid of, we cannot get away with. And recently we have introduced a practice where we remove back end turns of which have the fins. But I cannot say we are removing in 100% of cases, but yes, 70-80% we are removing. But front end fins, rounds of 3-4 rounds which are having fins, we cannot remove. It certainly will be there that we accept. That is our technology constant. And
Actually, sir, actually this like customer out of 2 wagons, customer has got this problem in say 8 coils only, sir. Like flat coils, hard coils, flatness is there, fins are there. So, but due to those 8 coils only, sir, it's hardly 8 tons. But customer was, customer was ready to return all this. He was not. He
Only for
want
8 tons. Only for 8 tons.
8 tons out of two wagons. So he wanted to return entire material, sir.
For 8 rounds.
Yes, sir. Eight coils. Mein there was
अच्छा,
an
8
issue.
coils. 8 coils में
There was a issue of flatness, fins, multiple cuts, and all these issues, multiplied. Because in some other competitor, they can sit and relax, sir, while their material is being drawn. But in our case, they have to keep an eye. Also, there is a production issues also due to this flatness actually. So,
actually,
well, I'm just wanted to say, sir, just impact of 8 or 10 coils out of 120 ton. So customer has stopped the production also, sir. They are like they get ready. I will not use your coil at all. After December, sir, I am unable to get the order for the last 5 months, sir. I'm unable to get that order customer back, sir. He was telling that first you sort out this flatness and fins. At least all those issues, if we can avoid, sir, like multiple cuts and all those issues, if we can look for some way, like you have just said, the grinding and all, I hope this will help out in these cases, sir.
This multiple cuts, yes, we accept that in certain cases it is there. As Madam already told in the presentation that in conveyor, because it is a chain conveyor where this coils are carried in the after laying head. So sometimes it gets entangled in the chain and it has to be cut. We try to segregate such coils and segregate it from the prime material, but sometimes it's not 100% possible in 100% of cases, because sometimes these cuts are hidden inside the coil, which are not visible from during inspection from the outside. So yes, we accept that in a few cases it may be there. We are trying our best, but because of this technological reasons, there may be certain very few cases where this problem is there.
Sir, last question, sir.
Yes.
Please, sir. What are the challenges in producing MIG grade, sir, at our Bhilai, sir?
MIG grade, we have tried around 3 years back.
Yes,
But with a lot of efforts, we made 2 heats and rolled around 20 coils. We supplied it to one customer in Raipur. That is accurate, if I remember correctly, accurate welding, something like that in Raipur. In fact, we also visited the customer during the drawing. They were able to draw it up to 2 mm, but after 2 mm, this rod was breaking. And it is because of the fact that hardness of the strength of the coil, this our wire rods was very high. It is coming around, the UTS was coming around 500, whereas the requirement was, I think, 400 max. It is because, again, because of old technology for wire rod mill, these requires dedicated hooks on the conveyors, which promote slow cooling, which is not there in our mill. So we cannot, in fact, we selected this grade for our new product development by RDCS and CMO last year, but we cannot make it a success. However,
actually, end product is 1.2 actually, 1.2, 1
1.2. Customers are able to draw up to 2 mm, but after 2 mm, it was getting getting broken.
Thank you, sir. Thank you.
Okay, okay.
Sir, good afternoon. This is Prashant from BSO Ahmedabad. I am looking after retail sales of TMT over here. So,
Yes,
by
sir.
chance, is there any case that we can supply secure in coil form directly to the distributors? Because in our distributor, we do have decoiling facilities. So,
it is a very big challenge, I will say, because there is some mandatory requirements. The moment some material is dispatched from a manufacturer, it has to comply fully to the specification requirement.
okay.
And suppose we give it directly to the distributor, then certain portion of the material, that is front and back end, will not have the requisite properties. So it will not be exactly good as per the BIS. As per the
Okay.
BIS, we have to supply material only, the entire material should have the required properties.
So, until let's say new mills come down, this problem will remain, sir.
This problem will persist, yes, sir.
Okay, thank you, sir. Thank you.
Thank you, Goel sir. Any more questions?
Good afternoon. My name is Kunal Singla, manager from Chandigarh branch. Sir, I have two questions. One is that the general feedback from our customers is that the scale formation is more in BSP wire rod coils. So, do we have a descaling facility in wire rod mill?
Again, I have to tell the same answer. We have very old mill. We don't have any descaling facility. Yes, I accept that our scale formation is a bit more. It is because of the fact that our furnace is pusher type furnace, not the walking beam furnace, which other modern mills are having. So definitely, it will our furnace limitation is there. So we also face this high scale formation problem in our mill also, because when during rolling also a lot of scale is accumulated beneath the our this stands. We also face this problem, but it is
Okay,
not
but sir,
that high. But I will say it is not that high. We got this feedback from SD Wire Indore, and we did certain testing, and we even they did testing on our wire rod coils. This scale, this it was hardly, I will say, 20% higher than the other manufacturers.
yes, sir. But in general, the customer feedback is that the scale formation is high. Even they are procuring from ISP wire rod mill also, and there I think we have the facility of descaling. But still, the scale formation is more in general sale material as compared to our competitor materials. So,
In
is there any
ISP, I
improvement?
think
Like, can we
ISP
do
should
anything?
not be, I think should be lesser than at least BSP, because they have walking beam furnace, they have descaling facility. So it should be lesser as compared to BSP, theoretically or technically, I can say.
Okay, sir. And so second question is that are we strapping the coils manually or through a machine?
Can you please repeat?
Sir, are we strapping the coils manually or are we doing it with the strapping machine?
This is strapping machine is there. Strapping machine is there, where
Okay.
straps comes and locking and strapping and all thing is done by a machine. It's a mechanical machine.
Okay. And we are putting that tag on every coil.
Yes, we are putting tag on every coil. In fact, at two places.
Okay. Okay, sir. Thank you, sir.
आलोक सर ये अभी जो हम लोग टैग लगा रहे हैं, नया फोटो दिखाया सर, वो कब से है सर? वो स्टार्ट जो आप लोग किए हैं सर, शिफ्टर वो सब जो डाले हैं?
वो तो अराउंड 1 ईयर से ज्यादा हो गया है।
ओके सर, ओके। और सर हम लोग पीसी ग्रेड बना सकते हैं क्या सर?
नहीं 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 नहीं, पीसी ग्रेड में अगेन वेरी हाई कार्बन, 80 कार्बन है। वो भी इस मिल में पॉसिबल नहीं है, नहीं है।
ओके ओके सर, ठीक है सर, थैंक यू।
Thank you. I think now we should take a short break before we go for the second session. Goyal sir, thank you so much to you and your team, Panigrahi ji and Bharti, for such a good presentation, and especially the videos, sir. They made us understand everything so well, and you have taken the questions and explained them so well, sir. Thanks a lot for taking out time for all of us. We will take a short break of 10 minutes only, and then we will start with the second session on product specifications and rolling challenges and quality issues. So it is 15:54 now, 3:54. I think we can assemble by say 4-5 and start the second session. जल्दी start करेंगे तो जल्दी खत्म होगा. With that in mind, let us assemble at 4-5 for the second session. Goyal sir, thank you. If you want, you can disconnect also, because I don't know. Normally, what faculties do, we take the questions after the second session, but since you have already taken the questions for your session, you can disconnect, sir. Thank you so much.
Okay, thank you.
Anupama ma'am, you are connected?
Yes, ma'am.
Okay, ma'am, we'll start. 1 more minute. Ma'am, in the meantime, you can share your presentation, ma'am, so that check ho jayega at least. Yes, ma'am, it is visible.
Is okay na, madam?
Yes, ma'am, we are able to see.
Okay.
रूपा मैम 1 मिनट और रुक जाए.
हाँ मैडम, ठीक है मैडम.
Okay. I am seeing 44 participants. Initially, it was say 52, 53. So we just wait for 1 more minute and then we start. अनुपमा मैम आपका वीडियो ऑन कर लीजिए. एटलीस्ट वी शुड रिकॉग्नाइज यू. इनफैक्ट हमने भारती को भी देखा नहीं. हु शी इज, वी जस्ट नो हर बाय वॉइस. अच्छा, हाँ, गोयल सर ने ऑन किया. भारती, यू आर नॉट विजिबल दो. आधा दिख रही हो. या चलो, नाइस. You presented very well. You are on mute, but good.
This is only 23 batch, only not even completed 2 years.
How about Panigrahi ji? आप एक बार just show your face. At least we should know you. है ना? क्योंकि कल को आप if CMO people are talking to you, yes, yes. Good presentation from both of you. Namaskar.
Thank you, ma'am. Thank you.
So, Lopa ma'am, we'll begin the next session, okay?
Thank you.
So welcome back, everyone. Let us move to the second session for today, rolling challenges and quality issues. For this session, we have with us Anupama Kumari ma'am, GM MWRM, Bhilai. Natarajan sir has already introduced ma'am, but she had sent a small introduction to me also. Ma'am is BE in Electrical Engineering from BIT Sindri. Ma'am, I'm also from your college only.
Oh, that's good, Shabnam.
Ma'am joined SAIL in 1993 as MTT in WRM in electrical section, and presently ma'am is in charge of WRM. Over to you, ma'am, for your session.
Thank you, Shabnam. Good afternoon, everyone. This is a small presentation about WRM, but I'll put on my video later, madam.
Okay, ma'am, it's okay. I was only asking just like that. It's okay.
We first go to the input from where we are getting the billets for WRM. So this is the steel melting shop 3 of Bhilai Steel Plant, which is a new steel melting shop. It is designed to produce 4.13 million ton of liquid steel per year. We have basic oxygen furnace here, secondary refining and continuous casting. We have 2 billet casters, CK1 and CK2. Both of them can, like CK1 is for 105 section and CK2 can get converted to 150 and 105 as well. Then we have one CV1 and CV2. They are bloom cum billet caster. This is the process flow for steel melting shop 3. Hot metal from the torpedo is coming here, then it is going to the BOF, then for the secondary refining and then to the continuous casting. This is the torpedo section. And here is the hot metal desulfurization unit. Now, Why am I showing you these slides from SMS3? Because the input billet that we are getting, and as Goel sir pointed out in his presentation, that we are reducing the sulfur content in EWNR. Once this unit has been commissioned, the quality of our EWNR billets became very good, and even the production of EWNR billets increased. Today, we can safely say that we are able to produce almost 97% of the cast billets of EWNR are of good quality. And as sir has also pointed out, the sulfur content here is to the tune of 0.010, which he says if there is a good feedback, we can reduce it further. Now, this is the converter shop, which has three converters of capacity 165 ton and 180 tons each. Then this is the secondary refining unit, the LF and the RH. And this is the continuous casting plant from where we are getting our billets. We can see here that it is a 6-strand continuous caster. And this is the billet caster, that is CK1, from where we are getting the 105 into 105 square billet of length 11.7 meters. One good thing that is put in the caster is the EMS coil, which is installed in the casting mold. This EMS coil actually creates a vibration which tries to reduce the inclusions and the air trapped while the casting is going on. So this again helps in improving the billet quality. That is that which will be supplied to the mill. Now this is the snap of the robot which is doing the tagging on the billet. Each billet that is coming from the caster is tagged. This is how the product has been branded. So all billet that is supplied to WRM is having this label and it is branded. Now coming to wire rod mill, Goel sir has covered most of the things. I'll only point out here that we have 3-strand rolling, and the ABP that has been fixed for us for 25-26 is 5 lakh tons. It was the same in 24-25 also. Our input billet size is 105 square into 11.7 meter long CC billets, and the product mix consists of both wire rod, coils, and TMT in the form of coil. For wire rod, we can roll plain wire rods from 5.5 to 10 mm dia, and in TMT, presently we roll only 8 mm and 10 mm dia in coil form. The billet weight is around 1.06 tons with a cross section that I have already mentioned. The coil weight is around 970 kg. The production that we have achieved in the last 3 years, I am trying to show that 3,67,000 tons in 22-23. In 23-24, it is 4,58,670 tons. And last year, we had actually a long capital repair which got extended. So the production is around 4,29,583 tons. Some of the improvements that are planned, we already have installed a new branding and a ring grinding machine. We are trying to convert our conventional stand in the intermediate group of 10 to 15 with a housingless stand. Here I would also like to tell the house that for stand number 14 and 15, we have installed the high speed or the HSS roll, high speed steel rolls. This is with a view that it will help us because the pass change is very frequent, as stand number 15 is the zero stand for our finishing area, that is B, C and D stand. So we have installed this high speed steel roll in stand number 14 and 15. With housingless stand, all the 4 stands, 10, 11 and 14, 15 will also have HSS roll. We also plan to have an additional compactor with its associated facilities and an automatic compacting machine, tagging, etc. This we hope to improve the quality of the packaging of our coil that will be processed through this new additional compactor. We have already installed QR code in our coil for labeling, and it is done for each and every coil. The grades that we roll here are grade 1 CAQ and grade 2 CAQ. IS 7887 grade 2, grade 3 that is SWR 10 and grade 4 that is again SWR 14. We have also rolled grade 7M and IS 2879 EWNR. In TMT that is IS 1786. We roll here FE 500D. We introduced FE 550D in November 24 and in May this year we have introduced sales secure. This is the first time we have rolled. We have rolled only 500 tons and now it has been sent to the stockyard for customer feedback. We also roll HCR billets in 500 grade. The rolling challenges that we are facing is optimization of the process parameters for TMT and HCR rolling. Basically, the cooling plays a very important role when we are making TMT coils and in HCR coils also. Since we are producing coils, so the process parameter is optimized in such a way that the billet, when it gets rolled and finished and when it is getting laid from the laying head, the first 2 turns are kept hot, few turns are kept hot so that it acquires the shape of the bend pipe and comes out of the bend pipe in a proper manner. After that only the water is made on and the TMT properties are adjusted. Now this is done in milliseconds. Our opening of the TMT valve, it takes about 1.3 seconds from the time the signal is given, and we have optimized the process in such a way that the few turns which are laid from the laying head in the front, they are around 4 to 5 turns, and same thing again is done in the back end. When we are rolling TMT, that time we are also facing the problem in our roughing group, and we also have to reduce the rolling rate because our cooling sections are not long. We have 2 sections of cooling. One section has 6 water pipes or the coolers, what we call, and the other next section, which is after the pinch roll and before the laying head, it has 2 cooling tubes. So this is how the arrangement is made for cooling, and the distance is not much. So that is why to acquire the properties of TMT, we roll the billet in such a way and at such a rolling rate that the cooling properties are well embedded, and all the total coil length, along the total coil length, we get even properties. That is, it is equivalent everywhere, wherever we check. So the rate of rolling is slightly reduced. Then there is generation of cuttings in our guides and very heavy guide failures during TMT and HCR rolling. So as you would have observed when you are asking me about TMT rolling and HCR rolling, I generally tell you that we are now rolling TMT. After the TMT rolling is complete, just before the changeover to plain rolling, we will roll HCR, because HCR again is a very hard material. Though the carbon is less, we have copper and chromium here as an additive, and this makes it a harder material to roll. The pass wear out is very, very fast. So the advantage that we want to take with the help of HSS roll is not exactly achieved, because now it is installed in only 2 stands. In case of plain rolling, supposing if we take say our pass change or the scheduled pass change, maybe after 3 days. In the case of TMT rolling, it has to be done the very next day, that is after 1 day of rolling, because the pass wear out is very fast. Now, in case of EWNR and grade 1 CAQ rolling, there is a requirement of no fin at the back end of the coil, because front end we cannot do much, though the requirement is both for front end and back end. We generally do the trimming at the back end.
Anupama madam, can you please move the slides?
No, I'll go to the other slide.
Okay, okay.
Here I am just trying to say that the conveyor, we are stopping the conveyor for doing the trimming in the EWNR and grade 1
Okay,
CAQ
okay,
rolling.
okay.
And this is how we are labeling our coil. This is the QR code that we had generated long back. And then we had this Made in India concept, which came for all the steel rolling mills. And the QR code has now been standardized, whether it is from SAIL or it is from JSW or from Vizag, anywhere, or even Tata Steel. The QR code design has been, and the label design has been standardized. So this is how it looks now. Now we have done one more thing on the feedback requirement of the CMO. There was a requirement that we should identify the front end of our coil. Now, since the front end, while it is getting laid and is put in the pallet conveyor, it generally gets inside, like it is the bottommost part of my coil. So after the coil has been taken out from the coil collector and is put in the rack, we were not able to identify which is the front end and which is the back end. So a very small thing has been done, but which I suppose will give a good result, that we have put a paint mark. As you can see, we are putting a silver mark on the side of the coil, bottom side of the coil, which when it is put in the rack, it will tell you that this side of the coil has the paint mark is the front end of the coil. I guess it is going to help while drawing of the coil to a thinner section. Now this is the SAIL secure rolling in coil form that we have done, and you can see our label says it is 3rd May 2025 in A shift. So we did this SAIL secure rolling with the help of our quality. The quality people were there to check all the parameters, and we did some modification in our pulling lines so that the coil that we are getting, it has uniform properties throughout. And we are just waiting for the customer feedback. And if the feedback is good, then we will be able to produce this in section 10 mm in all the 3 strands at a time. We have now tried it only in B stand because of a smaller trial order. But once if the feedback is good, we will try it in our C and D stands also. The rolling defects and the other defects, Goel sir has already discussed. There are 2 kinds of defects that we are getting. One is the multi-end and another is the customer complaint for material breakage. So I have shown you the SMS3 layout and how we are trying to get a better and a refined chemistry so that material breakage can be controlled. And as someone was asking during the question answer session with Mr. Goel, that how far can we reduce? So if we are taking a 6 mm coil, my suggestion would be same as Goel said, that please ask your people to use a 5.5 mm dia coil, or else you can increase 1 die. If we are using 3 die for drawing, then if we increase it to 4, then the breakage will get reduced. And multi-ends, they occur because the conveyor on which the coil is passing, sometimes the coil gets entangled because of the hook like things that come out of that chain. So they are cut at regular intervals and the chain is also changed. I would also like to inform the house here that we have changed the conveyor quality and we have introduced a harder quality material in D stand that we because we are rolling 5.5 in D stand mainly. We are also going to introduce that in C stand shortly in the next repair. Now a look at the cost of production and the contribution for the last 3 years. This year, I have shown you the April figures instead of the 24-25 because the average figures are not available. So for April 25, we can see that the contribution margin is very good. So we expect better orders and the market seems to be good. So this is all. Thank you. Now we can have some questions.
Thank you, ma'am. Thank you for the presentation. The house is open. And thank you for switching on your video also. We can take, ma'am will take questions now. Please shoot.
I can stop sharing my slide.
I don't know, ma'am. Abhi rehne dijiye because sometimes they ask na ki go back to some slide or something. So,
Okay.
any questions, please? Ma'am से पूछना है तो. I think आप unshare कर लीजिए, ma'am, है ना? You can explain whatever they ask. I request people to switch on your videos. I need photos for the tweet. Please switch on your videos and please like shoot your questions to Anupama ma'am.
Question answer is already over, ma'am, because Alok Goel sir has answered most of the questions.
Yeah, I understand, ma'am. लेकिन फिर भी.
Yeah. Hello, Kunal.
Hello, ma'am. Good evening.
Hello, how are you?
I'm fine, ma'am. Thank you.
You are getting all your material from WRM, no?
Yes,
No
ma'am.
problem, Sapur?
No, ma'am. No problem in getting the material. But yeah, few concerns regarding the quality.
Yeah, you can share that.
Yes, ma'am. Thank you.
Ma'am, we had this we started PACE program in September, and in October we had a wire rod coil from ISP, and I think it was Ayushi who said that she was disappointed कि भिलाई से कोई faculty नहीं है. Was it you, Ayushi?
Yes, ma'am.
You said
It was me.
ma'am, I have started recently looking after
WRM,
and
Yes.
मुझे एक बार ध्यान में था
Yes,
कि
ma'am.
we have to cover
Yeah.
wire rod coil, so it's done today. I hope that makes you happy.
Yes,
I
ma'am.
think
Thank
one
you
step
so much.
ahead, ma'am. She visited Bhilai Steel Plant and she came down to WRM to have a look at the products firsthand. And
Okay.
I have also explained to her what are the problems when they ask, no, how you can cut the front end and the back end. She has seen the system. Maybe she'll be able to tell how it is.
Yes, ma'am. It helps a lot to see the production ourselves, the mill and everything, and also it helps build a rapport with the production people.
Ma'am, we have Goel sir here with us. CGM MWRM.
Sir, good afternoon, sir. Welcome, sir.
If the house has any question to Goel sir also, it can be, I mean, you can ask, you are free to ask.
Okay, good opportunity.
Yes.
Anyone has any more questions, please go ahead.
Sir has been a listener throughout the presentation. He has also listened to Goel sir's presentation.
Okay.
Good afternoon, ma'am. Good afternoon, Goel sir. I am Virender Negi, branch manager, Ghaziabad. So I joined late actually. I don't know whether this question is asked by somebody or not. I just want to ask why there's a issue of front and tail and cutting in our product, whereas our competitors there's no such issue of inferior quality in rear and front end of the coil. And is there any plan to mitigate this? Because of this, we are not able to sell TMT in coil form to our customers, which is a big market and a growing market.
So you're talking about TMT coils, not wire rods.
Yeah, I'm talking about TMT coil. In TMT coil, there is a guidance from plant that 60 meter, roughly 5 or 6 length of TMT coil are to be cut from front and tail end of the coil, because it is having inferior mechanical properties.
Sir, as Anupama madam already told that when this wire rods, this TMT coil enters into laying head, it cannot have that high strength. Otherwise, that material, that laying will not be take place. So to ensure that initial 3-4 rounds are properly laid in the laying head, it has to be softer. That is, property has to be around 350 to 400 only. Only then it can, that laying is possible. So that is why
Okay.
it is a
Okay.
technological requirement. Even in modern mills, such requirement is there. Only difference is that their number of rounds are lesser as compared to our mill. But this is a technological requirement. Few rounds of front and back end will have inferior properties. So these have to be cut down.
Okay.
Only
Okay.
difference is we cannot cut in our mill, and modern mills have the facility to cut in their own mills. So that is why this load is being
So,
taken care
sir,
of by
you mean to say that
stockyards.
the competitors who are supplying material in coil form, they are able to cut those front and tail, front end at the mill itself?
Yes, yes. Modern mills have this facility. Even our BRM, bar and rod mill have wire rod line, where TMT coils were produced way back in 20 and 21. Then also we were cutting these front and back end rounds. But unfortunately, this wire rod mill, when this was established in 1960s, this concept of TMT was not there, and hence this facility was not visualized. And now this logistics do not permit to introduce this kind of thing in this old wire rod mill. That is a limitation we are having. That is why we have to send these coils to stockyards, where these are decoiled and the initial 20 rounds each in front and back are cut and removed.
Okay. Okay.
मैडम
Okay.
आपको अनुपमा मैडम आप कुछ बोलना चाहेंगे?
Why I was asking it is because there is a good market for it, because now people are going for cut and bend and these kind of service center. So हमारा जो भिलाई की मिल है, we are not able to supply those coils to them. The
Yes, sir,
option
yes.
of recoiling and decoiling the material at stockyard, state stockyard was explored, लेकिन वो feasible हुआ नहीं, because the recoiling of the cold material and then again
It's difficult, very
coiling it
difficult.
will not be possible at stockyards. So वो we are altogether left behind in this segment.
Sir, अभी in market, other manufacturers they are making TMT coils up to which diameter?
They are making up to 12 mm.
12
GSW,
mm.
RNL, up to 12 mm they are making, and 12
12 is
mm is
the
easily available in the market.
12 is the upper limit for this TMT coils.
So Tata also started supplying in 16 mm now.
Okay, okay, okay.
This is Sonu Dhanwar from BSO Hyderabad. Hello.
Actually, this
हाँ,
TMT
you
coils
know
has number of advantages in the terms that for bars we require a very long cooling bed. This is around 100-meter length. So in case of coil, since it is coiled itself, so there is no need of having a very long cooling bed. There is no need of any shear after finishing to cut down in the desired lengths. So it is a very big advantage to manufacturers also. And also
Sir,
customers can decoil it, and they can cut down in any length they want. So that is very flexibility for them also. In that sense, TMT coils is a much advantageous product.
BSO Hyderabad, go ahead. Please ask your question.
सर ये जो हम इसको कट कर रहे हैं आगे और पीछे का, इसको जैसे सर अभी डिस्कस कर रहे थे और यहाँ भी हम डिस्कस कर रहे हैं इसको स्टिरअप मेकिंग में, तो इसका कोई स्पेसिफिक ग्रेड है कि इससे नीचे नहीं होगा? लाइक 415 अगर 500 का कॉइल है या 550 का कॉइल है, तो उसका कोई होगा कि इस ग्रेड तक
नहीं
एटलीस्ट
सर, ऐसा इनफैक्ट एज पर BIS अगर हम 550 दे रहे हैं तो इंटायर मटेरियल शुड मीट दैट प्रॉपर्टी. अगर स्मॉल पोर्शन भी नहीं है, इट शुड बी रिजेक्टेड, इट शुड बी स्क्रैप्ड. देयर इज नथिंग कि आप उसको डिफरेंशिएट करके मल्टीपल ग्रेड्स, दैट इज नॉट अलाउड बाय BIS.
मेरा ये कहना है कि कट होने के बाद मटेरियल और सेपरेट, हमारा जो लो ग्रेड मटेरियल है जो हमने कट करके 12 मीटर के 3 पीसेस आगे और पीछे करके हमने उसको अलग स्टैक कर दिया, नाउ मेरे ख्याल से स्क्रैप की तरह यूज कर रहे हैं. तो अगर वो मटेरियल तो अलग हो गया, अपना कॉइल 550D का है जो हम ऑलरेडी स्ट्रेटन करके और रेगुलर देख रहे हैं, लेकिन जो आगे नीचे का पीस जो हम कट कर रहे हैं वो हमने मटेरियल अलग सेग्रीगेट किया हो, उसका कोई ग्रेड हम सर्टिफाई कर सकते हैं जिससे हम स्टेट ऑफ मेकिंग में किसी तरह से
नहीं,
यूज
ये
कर सकते
एक्चुअली पहले ये
नहीं, वो
पॉसिबल
हो
था।
नहीं पाएगा ना, बिकॉज आपकी
पहले ये
बिल्डिंग का
पॉसिबल था।
डिजाइन इज फॉर
अभी तो
500D।
अभी तो एम्बॉसिंग हो रहा है। ग्रेड इज बीइंग एम्बॉस्ड इन द टीएमटी इटसेल्फ। सो बीआईएस 2019 में इसको इंट्रोड्यूस किया है। तो अभी तो इट इज नॉट इवन थोड़ा सा भी वाईएस कम होने से इट हैज टू बी स्क्रैप्ड ओनली। देयर इज नो
नहीं
स्कोप और
होने
नो
से भी
प्रोविजन
अगर
फॉर।
हम इसको डेजिग्नेट भी कर दे लोअर ग्रेड में, तो वी कैन नॉट यूज इट बिकॉज आपकी बिल्डिंग विल बी डिजाइन फॉर 500D, और आपका जो स्टाइरप्स है इट हैज टू बी 500D। अगर बिल्डिंग 500D में डिजाइन है और स्टाइरप्स आपका 375 या 400 है, तो वो तो दैट वॉन्ट बी एक्सेप्टेबल।
नहीं, सर का क्वेश्चन ये था कि अगर वो 415 की प्रॉपर्टीज मीट कर रहा है तो कैन वी डेजिग्नेट इट इन 415 इफ देयर इज
ये
रिक्वायरमेंट।
लेगा ही नहीं ना सर, 415 कोई लेता नहीं अभी।
वो भी नहीं कर सकते हैं, वो भी अलाउड नहीं
हाँ,
है।
खरीदेगा नहीं कोई अभी।
यस सर।
स्टीरअप मेकिंग में तो हो सकता है, वैसे भी हम काफी मटेरियल तो डाउनग्रेड करते ही हैं, अगर मतलब काफी बार होता है कि हमारा
नहीं नहीं, स्टीरअप्स भी जो है ना 500D के ही होने चाहिए ना आपके। स्टीरअप्स इज नॉट ओनली है कि बांधने के लिए नहीं है उसको, वो उससे लोड डिस्ट्रीब्यूशन भी तो होता है ना। अगर आपका टीएमटी इन ए कॉलम और बीम इफ इट इज 500D, द स्टीरअप्स हैज टू बी मैंडेटरी 500D, वो 415 का नहीं हो सकता है।
सर यहाँ रियलिटी सेक्टर में हमारा 550D प्राइम मटेरियल का यूज कर रहे हैं वो, लेकिन 8, 10, 12 टायर को वो सेकेंडरी वाला ही यूज कर रहे हैं एंड दे आर सेटिस्फाइड विद दैट। तो अगर हम अपने इसको डाउनग्रेड करके अगर कुछ स्टेटअप बनाए तो आई थिंक दे विल एक्सेप्ट इट, मतलब देयर इज अ चांसेस, मतलब पोटेंशियल इन दैट, दैट्स व्हाई आई एम आस्किंग। रियलिटी सेक्टर में ऑलरेडी वो सेकेंडरी ही यूज कर रहे हैं फॉर 8, 10, 12 टायर।
हाँ, रियल स्टेट में कर लेंगे, पर हमारे जो कस्टमर्स है उनकी तो स्पेसिफिकेशन 500D की है, 550D की है। उसमें अगर ये बोलोगे स्टाइरप्स के लिए 415, तो लेगा नहीं ना आपसे। रियलिटी में तो प्राइवेट वो है, कंजम्पशन वाले हैं, तो दे कैन डू एनीथिंग, उनको तो रोक नहीं पाएंगे। बट आपसे अगर एलएनटी या एससीसी या कोई और ले रहा है, तो उसको तो ही वांट मटेरियल, एंटायर क्वांटिटी ऑफ मटेरियल इन 500D और 550D, वेदर इट इज स्टाइरप्स और कट बैंड या कॉलम बीम का जो भी मटेरियल है, तो वो तो एक ही ग्रेड में होना चाहिए।
गारंटी शापोर जी जैसे कस्टमर के लिए तो वो ठीक है सर आपका, बट अगर जहाँ जहाँ हमारे पास पोटेंशियल है या कुछ कस्टमर है या कस्टमर बेस है जहाँ इनको हम यूज कर सकते हैं, जैसे मैं बोल रहा हूँ मेरे पास है, तो तब हम क्या डाउनग्रेड करके रिक्लासिफाई करके कुछ कर सकते हैं क्या?
नहीं सर, इन दैट केस आपको तो टीसी मांगेंगे ना। टीसी में तो आपको फिर 500D लिखना पड़ेगा। 415 लिखेंगे तो फिर ये मिसमैच होगा कि आपका ब्रांडिंग 500 का है और टीसी 415 है, वो इशू आएगा।
बस मैं सर इसी का ही सॉल्यूशन आपसे पूछ रहा हूँ कि हम ये एग्जीक्यूट कैसे करें, एक उसका ग्रेड कैसे पता करें एंड देन उसको सर्टिफाई कैसे करें।
नहीं सर, वो प्रॉपर्टीज तो हम लोगों ने चेक किया था। इनफैक्ट वो सीएमओ हेडक्वार्टर कलकत्ता ने भी कई बार इसको टेस्टिंग किया है। तो प्रॉपर्टीज तो टन बाई टन वेरी करता है। ये बिल्कुल फ्रंट एंड में आपको 350 मिलेगा, फिर वो बढ़ता जाएगा, फिर 400, 450 लाइक दैट। सो इट इज़ नॉट पॉसिबल टू प्रैक्टिकली डिफरेंशिएट दैट कि इसके ये इतने टन्स में ये है, इतने टन्स में ये है। इट इज जस्ट नॉट पॉसिबल।
ओके सर, थैंक यू सर।
थैंक यू।
Any more questions, please? और कोई questions है? Otherwise, we will close.
Sir, I have a question. Alok sir, Rahul Bose from BSO Hyderabad.
Sir.
Sir, recently, sir, from February and March, we had issues wherein wire rod coils, the tagging of the coils, which was there in the TC, and the actual coils which have been dispatched did not match. I took up the issue with plant as well, but I have not got a concrete solution on this.
So in certain cases, it is there. We accept it. We are trying to improve.
Sir, it is not certain cases, sir. It is about 100 to 200 tons in a dispatch of 1,000 tons. So it is not certain cases. It is lapse.
which is happening months on months. We have to do something about it. In this particular case, we have a customer who exports the product to outside the country and he needs a proper documentation.
So were
So
these coils dispatched on direct dispatch basis or from
they're
stockyard?
always direct dispatch, sir. Hyderabad will not be able to work out on road dispatch basis. So it is 100% direct dispatch only. But we have been raising this issue. The customer is Elemental Connectors, you must be knowing. So he also has the issues of head cracking, which we also took up. I had written a mail also. Around 800 tons of material he wanted to reject. But at that point in time also we didn't get that much support from the plant. Nobody came to see the complaint. And in this particular case, why should there be a mismatch between what is being dispatched and what is there in the TC? There should not be, na sir. We are a primary producer, and this kind of lapse is not at all warranted for.
अनुपमा मैडम है क्या लाइन में?
Yes, sir. Yes, sir.
मैडम ये जो राहुल जी एक पॉइंट उठाए हैं वो मिसमैच ऑफ हीट नंबर्स एंड कॉइल नंबर्स, थोड़ा सा आप वो जो
Yes, sir.
स्कैनिंग करके
This
आप लोग कर रहे हैं
was
लोडिंग, स्कैनिंग करके वो थोड़ा बोलते बता.
actually this came to our notice, Mr. Rahul, and after that we have taken certain steps.
Ma'am, when I raised the complaint, that was for the supplies of February, and the customer has informed that in the month of March as well, we are having the same issue. The customer has already shifted 30% of his buying. Is buying from JSW now, and if we lose him, it will be a big loss because he lives around 1,000 to 1,200 tons a month.
On month, yes. Elemental Connectors, actually, when we had visited BSO Hyderabad, that time also the person from Elemental Connector, he had come to visit us, and he was also a part of that presentation, and we had gone and seen how and what he is doing. So we, as Goel sir had said, that we are improving and we have taken certain steps so that the heat mismatch does not happen. And you get the same TCs as the heat that has been tagged in the coil. So there was a mismatch in the heat number that was given in the coil and the TC that was given to you later.
Ma'am, just wanted to understand what is the process wherein the material gets tagged in a TC? Why do we have this issue at all?
The heat numbers are given as per the rolling heat that is going along. Okay. So we have the same material in the furnace and it will be rolled in 3 strands, B, C and E. Now when we are dispatching it, the heat number that is there that is tagged on the material, the shipper who is loading it will take the same heat number and he will try to prepare a DA or a dispatch advice with the same heat number. Now, once the heat number and the dispatch advice is being made, then there is a process of connecting it with the test certificates. So in that case, there was a difference. The number that was tagged on the coil and the number that appeared in the TC, they were two different numbers. So we had this problem.
Can I assure the customer that this will not be happening in future?
Yeah. Yes, you can do that.
Yeah, thank you, ma'am.
Okay, Rahul, and if it happens again, you can take it up with ma'am or the department separately. Okay. Now that you have understood the problem, you will be able to understand what might have gone wrong where. Any more questions, please? If there are no more questions, then I think we will wind up. Thank you all for your active participation, which has made this a very insightful session. I request Lopa Mudra ma'am, are you there? Yes, ma'am. For
Yes,
your
ma'am. Yes.
closing remarks, please, and any suggestions that you have.
Thank you so much, madam. We are in the 9th episode of PACE. And as we can see, madam, the attendance of PACE from day first episode to 9th episode, it is increasing, and we are getting good feedback about PACE. And definitely, when the plant people are giving any presentation and the start and the end meets, I'd rather say. Thank you so much to the team of BSP who have made a wonderful presentation. And regarding the part that we are discussing, ma'am, whether we should continue for the next episodes of PACE, whether in the first half or in the second half, I'd request if any guidance is given by this group that what would be better if we'll continue in the second group, second half, or we'll continue with the first half. That is one suggestion I want from the participants. And the second is any specific product in which they are facing any issues, CMO particularly the product executives, then we can take up with that product in the next sessions for discussion. So, but besides that, many thanks to Shabna madam. She organizes it so well, the space program, and coordinating with plant and coordinating with CMO. Thank you so much, madam. And
For the
special
attendance, I think it has gone up because now you are mailing it to all CMO executives, right? Yeah, that because I think there was lack of information, ma'am. So that was a good idea from your side, and thank you for all your support on all your you are regularly giving me the Zoom link also and the video recordings also, which I'm uploading on we are uploading everything on e-Abhigyan. So people who have missed or who want to see the presentations again, they can go to e-Abhigyan. So yeah, I'm very thankful to the faculty from Bhilai for making this a wonderful session and for sparing your valuable time. One more thing, Ropa ma'am, I need your help is that we are not sure whether we should take up pipes and CRNO because they are not dealt with all the like branches. So for these two, if the people want, then we will include these products in the subsequent sessions. So for this, if you could just find out and let me know, that will help. Okay, thank you everyone for your participation. Happy learning.
Ma'am, one more request.
Yes.
I'm Isha from BSO Kolkata.
Isha,
I have not attended the wire rod session of ISP. So
Yes,
can once again ISP wire rod
Isha,
session be held?
the recording and the recording of the session and the presentation are uploaded on e-Abhigyan. Once we complete all the products, then going forward, if CMO wants, then we can have repeat sessions or in some other form, maybe taking different segments instead of products. We have to decide yet on that. But immediately, as of now, repeat karna thoda mushkil hoga. You can see the recording also, Isha. So everything, I mean, you will miss nothing. The presentation also will be there and the recording also is there.
But that is not interactive, like we cannot ask questions in that.
I understand. So if, see this kind of feedback you give to Lopa ma'am, if she wants, maybe if required, because initial, I think sessions, most of the people have missed. So for some products, we can have a repeat session. I have no issues. If you want it,
Yes,
that,
ma'am.
give your suggestions to Lopa ma'am, and then we'll have it like that for whatever.
Okay, ma'am.
Okay.
Okay, thank you, ma'am.
Okay.
Madam, I have one more suggestion.
Haji sir, boliye.
Actually, we were not knowing that this kind of thing was going on. You told this is 9th such presentation.
Yes, sir. We started in
The
September.
day I got your call, that moment I came to know that this kind of thing is going on. So I will request that you spread this thing to all the concerned that this kind of thing is going on, and maybe your participation may increase and so many
In
interested
fact, I've
persons may
been
join.
thinking that CMO ka WhatsApp group maybe next time onwards, I will post it 2 days
To
before.
plant also, but to plant at least to mills
The plant also. See,
and
plant
RCL.
HRD, I am putting in plant HRD group.
But
So
we
that
didn't
plant
get any.
HRD, but most of the times I have seen that except the plant that is involved, जैसे आज भिलाई है तो भिलाई का RCL plus WRM, others have not shown interest. I have tried to approach them, but okay, अब मैं प्लांट HRD से रिक्वेस्ट करूंगी, LND से rather, कि वो प्लांट में सभी को इन्फॉर्म करें. This I will start. Thank you.
At least you can send mail to quality and all mill HODs.
अच्छा, quality of all the plants. You mean to
Yes,
say for
yes,
different
yes.
plants also?
Yes.
Okay, okay,
Because
sure.
because
I will do
suppose we
that, sir.
attend presentation of other plants, we will also learn a lot of things.
I understand. ठीक है sir. I will do that, sir.
Okay,
I will
madam.
involve the plant HRD, LND, and I will see that the communication is sent to all the plants quality departments. ठीक है
Yes,
sir.
ma'am. Yes.
Thank you.
Okay.
Thank you for
Thank
the
you. Thank you.
suggestion, sir. Okay, then we wind up today. Thanks everyone for joining, and thank you Bhilai team. Thank you so much. Thank you Lopa ma'am, especially to you. See you all with next episode of PACE next month. Thank you.
Thank you.
Thank you, ma'am. Thank you.
Thank you.